on the state budget, which is why I had sort of interest in this data and why I brought it to my uni to try and get some interest and some excitement about it. This project is not a funded or a grant project. It doesn't have an active research project. It began in some ways as who's our director of the Network Science Institute, Patty Mabry. Okay. Oh, she's not joining us. Okay. Well, this is our director for the Network Science Institute. Hi. I think you're on to. But so this project started off as a way for me, as I was learning Neo4j, to work with some data I was familiar with. And it's become kind of it's not up to date in terms of the most recent years, but it's for the years that it covers, it is a comprehensive data set for the state government. I'm going to show you in a little more detail here what we have exactly in the database. So we have the state Legislative Services Agency started making the data available in a machine-readable format in 2014. We have the set 14 to 16. 17 is available, but it's not been added to this database yet, and 18 should be available in the next couple of months. They're just wrapping up the current legislative session right now. And so it's available if we have someone who is particularly interested in this research or wants to advance it or use this database, we can fairly easily add in the most recent years. But so this database, what it gets used for the most is as a tech demo for what we can do with graph databases rather than for a research project necessarily. That's what we're doing today. So it hasn't been necessarily kept up to date, but it wouldn't be a big task to refresh it. So we tried to include as much data as possible from bills, committees, amendments, legislators, and then we can track the relationships between all of them and see how bills move through the network of legislators and committees and how they change over time. This is an example of some of the data we'd like to add. Obviously, the 2017 data is the most obvious thing. And we have conference committees and study committees, which I don't know, are any of you particularly interested in public policy and the legislative process? But we have the standing committees now, which are the committees that meet every year, whereas conference committees and study committees are kind of one-off event committees. We have data on them, we just haven't built them into the database yet. They're less sort of central to the network. And more information about the individual legislators. We have some data about which district they're from, party affiliations, but available online in this database, which is separate from the LSA one, which we've been working from, as more enhanced biographical information, which I think would be interesting to include. And the one that I would particularly like to see included would be the campaign finance information, which is information about who donates to which organizations, and then what do those organizations, on whose race or whose election campaign those organizations spend money. So I'm not aware of any other source at the state government level that has that kind of information on how individual state legislators and senators are financed. Yes. Yes. Right, yes, we could go back. So before 2014, only PDF data was available. 2014 onwards, it's available as PDF and JSON. So we were able to work with those JSON files and build this database I'm going to show you today. But before that, the same data is available, but only as a PDF format. So we'd have to scrape the text and OCR it. And so it'd be great if we could include that, but that's a lot more work to go back further in time. But it'd be an interesting source of data to include. And then other data sources, as people come to us, we're happy to include other data. If there's a particular research question somebody wants, we can definitely look in ways to include that data. So it's probably the part you're more interested in seeing, how we're storing the data. So as I mentioned, we have the comprehensive set of JSON and PDF files on our drive on Geode, which is the university's research file system. And then the JSON data we took out and built into this graph database using Neo4j. So I know we have a couple of people I've mentioned they've used Neo4j before. I'm going to talk a little bit about why we're using a graph database for this project, how the graph database works, how it's different from your traditional relational database model. Does anybody, so I'm going to do this next part. I don't want to be patronizing. I'm sure you guys are all experts, have done a lot of data manipulation and data science, but I also don't want to skip over something that's important. So let me know if it's boring or if this is all stuff you've heard before. So this is a traditional relational database model, or at least is my example. So on the left here, we have a table, as you would see it in a relational database, where we have all of the elected representatives in Indiana state government. And we have on the right, the table containing the names of the different bills that were considered by the legislature. So how you would traditionally build this relationship would be with this primary key, foreign key structure, where each, do we have a pointer to the screen? No. You're not filming me, right? I can just walk over here. So we have the primary key for this senator, and his ID number is represented in the bill table on the bills that he sponsors. So that's your traditional model, as you would see it in a relational database. You have two tables and you match them up based on some common field. So with the graph database, instead of using tables, each record in the database becomes a node in the network. So it contains not only information about itself, but about the other nodes that it's connected to. So instead of looking at a traditional entity relationship diagram with a series of tables, as you might with a relational model, you'll see that a graph database schema looks more like a network diagram, where you start to see the structure between nodes and between records in the database. So colors, I'm going to show up too well, but the idea is this is a bill of the class has its own class. So it's a bill class, and this is the legislative class. So these nodes belong to particular groups rather than belonging to particular tables, but they all exist independently of one another. If that makes sense. It's probably easier to show with a demonstration, which I'll get to in a minute. So why do we want to use a graph? So I tried to come up with some questions here. And for those of you familiar with the relational database model, I just gave you a short demo there of what I'm talking about, that you think using those two tables, how relatively complex it would be to answer these type of questions using that tabular structure. Particularly, we're going to focus on this first question. So who sponsored one bill but didn't sponsor the other bill? So with the tabular structure I showed, first thing you have to do is look across and join the two tables and say, okay, who sponsored HB 1001? Then do the same query again and say who sponsored HB 1003, and then who's in both sets or who's not in both sets. I mean, obviously you don't do that. You write a SQL query, which is recursively moving back and forth between the two tables, but you have to do multiple, and you have to look at each record multiple times and produce these two sets to compare. So compared to a graph, that's quite a complex task. With a graph model, we just have to do one pass of the network to see which nodes are connected to the nodes that we're interested in. So we don't have to have this recursive structure where we're going back and forth between records. And so it makes it much easier. Not only is it easier to write the query to do this kind of search, but it requires much less processing to simply visit the records a single time and look at the network. So I'm going to switch over and show you the network, show you the database. Oh, do I need to switch my screen? You want to jump over and do that? Or? So if you haven't seen it before, this is the Neo4j browser-based interface. There is a desktop application you can use as well as a command line application for administrative tasks. But this way, you can interact and visualize the network without having to install anything on your machine. You can connect to it remotely. In fact, if I give you my IP address, you can go to it yourselves and take a look. Although you don't have accounts, you wouldn't be able to connect to it. So this is the sort of summary information about the database. So these are the different node classes we have in the network. We have amendments, bills, versions of bills, legislators, and standing committees. So you can think of those in the way you might think of tables in a relational model. But these all have something in common in that they all belong to this class, but they're all separate in that they're all separate parts, separate entities in the network. And these are our relationship types. So you want to go ahead and switch that. But, the nodes can be connected to one another. We can give a particular label to that type of connection. So for example, we can have a bill and a legislator connected by a link of the authored by type, or you can have a bill and the committee with it connected to by the assigned to, I think, or heard in, or whatever I called it, type of connection. So you can do searches based on the type of connection as well as on the type of node that you want. So let me show you some queries I put together. So just full disclosure, I originally came up with these demo queries for a presentation at the School of Public Health. So we're going to focus on healthcare policy today and opioids and abortion legislation, because that's what they asked me to talk about. But I'm just using them as examples. So hopefully they communicate the idea of what we're trying to do. So first couple of queries, I'm going to show you how we can do the same kind of queries you might see in a relational database, but with a graph structure. So nothing too exciting in the first one. Here we're looking at bills, in which the digest contains the phrase word opioid, and we're going to return the name of the bill from the digest. So this is just a quick aside. This is a query language. It's called Cypher, created by Neo4j for their database, but it is available as an open source language, and it's been ported to a number of other graph databases. We're working with one called Agents Graph as well. We're evaluating, and that also uses the same query language. Unfortunately, as of right now, there's no sort of common standard language for graph databases. In the same way, SQL is pretty much universal for relational databases. There's, say, Cypher, Gremlin is the other one that you might see. They're probably the two biggest ones, but then there are others called like GraphSQL or GSQL, and there's a whole bunch of variety. I like Cypher just because it's very visual, and I'll show you some more as we get further through some of these demos. You'll see a bit more how it works, but I found it quite an intuitive language to pick up querying. So okay. This is not, as I mentioned, not a super exciting one, but here you see we've got returning the name of the bill and the digest, and somewhere in each of these digests is the word opioid. So now, and here's a nice example. With this one, we're going to look at who are the legislators who authored the bills with the word opioid in, and then return some information about the bill and the author. Here you see what I mean about the kind of visual nature of Cypher. So this is the main part of the query here. So with the curl brackets or parentheses, we're looking at a node, and then this is the relationship, and then this is the other node that we want to look for. So really we're sort of doing a little diagram of the pattern that we want to look for in the database, and then adding some sort of qualifying criteria here. So now we're returning data from two node types. So we have data from the legislator class and the bill class, and we're pulling them together in a single result set based on that particular type of connection. Obviously, we could change that if we wanted sponsored by or co-authored or co-sponsored. We have different connections between bills and legislators depending on what we're interested in. But anyway, so that's how you can do SQL type queries. And now I'm hopefully going to look at some more network type queries. So here's the same query again, but instead of returning these particular attributes of the nodes, we're going to look at the network of bills and legislators. So it gets a bit more interesting. So it's a little faint. I don't know if it's the resolution here on the screen, but you can see the colors here. Zoom out a little bit. So the yellow bills are the legislators, and the purple nodes, the yellow nodes are the legislators, and the purple nodes are the bills. And you can see the relationship type here. So we see Senator Merritt authored SB 270. Well, SB 270 was authored by Senator Merritt. We can color code these. The color coding is just something you can play with, as necessary, just to visualize these. Let's say if we click on Senator Merritt, and we can see what we know about him: last name, Republican, senator. He was in the legislature all 3 years that we have in the database. First name James. The bills, we have a little more information, as you might imagine. So here we can see the digest of the bill. See committees it was assigned to, I believe, co-sponsors. No, and it looks like this bill didn't really go anywhere. Short description: coverage for abuse deterrent opioids. Not concerning insurance. So it tells you, gives you some of the metadata about the bill. And as I mentioned, we have all the PDFs of all of these bills. So if you wanted more detailed or wanted to read the actual text, we have all of that in a separate file system. And then, it'd be nice. It'd be great, of course, if we could have some kind of web interface which would bring them together. But anyway, just to give you an example. And you see this, we only queried for authored by links, but it also returns in this tool some of the other. You've got co-authored there, sponsored by, simply because both those nodes were present. So it just visualized both those nodes. But obviously, if you want to run a query which then returns some data, exports it from the database, you can filter those out. It won't do that. It just does that for the visualization. So in this one, so we looked at this network. We found a particular bill we're interested in. It's HB, which one did I pick? 1449 from 2015. And so here we're starting to build. Let me close this. Starting to build up. Oops. A more complex query here. So we have bill version, and the standing committee. So bills, there are multiple bill versions for each bill, and a bill version is assigned to a particular committee. You see here we didn't specify the relationship type, so we're saying any type of connection between these two. is what we're interested in. And just as a brief aside, so you can have matching criteria. You can have, if you think of it like a where clause with SQL, you can put it here underneath as like where A contains X, or you can put it within the description of the node here. I don't think it makes any difference in terms of performance, but just it can make it easier or more clear to read these queries. So here we see the network for this particular, or the matches this particular query. I'll go off the side of the screen. So you see HV1, 4, 9. Hopefully, can you see that on the bottom here? Oh, here, let me scroll down. There we go. So we see two versions of HB 1449, the introduced version and the committee version. But from this, we can see, well, this bill was first assigned, the introduced version was assigned to this committee, the public health. And we can see some information about the committee. It's kind of messy to read as a human, but it's useful for the database because you see it is able to track all the other nodes that are connected to this bill in the metadata, and then we can search through it. And we see members of the committees, chamber, full name, chairman, etc. So then we can start seeing, well, what happened with this bill? We know it went to this committee, and then it went to the second committee, but it looks like it didn't go any further than that. It didn't progress any further through the legislature. So I'm just trying to show how we can get to sort of more focused queries rather than having these big sort of hairballs, which you get when you write more general queries. And particularly with this database, all the nodes are quite densely interconnected. There's a lot of relationship information we built into this database. So now we're interested in that side. We're interested in that bill, so we want to know, well, who's on these committees who reviewed this bill, who voted on it? Again, a little messy, but hopefully we can see. Let me zoom out a little bit. So now you start to see the structure here. So we have the committee two committees that it was assigned to. It doesn't move around too much. And we can start to see, well, who's on those committees? Who is it who voted on those bills? And we start to see this interesting, well, maybe it's not that surprising, but we can see the people who signed on, who are sponsors and authors of the bills, are also on the same committees where the bill was heard. So we can say this bill was only heard in committees, or the fact that a particular legislature agreed to sponsor or co-author the bill increased the chance that it was going to be heard in the committee, for example. So not a particularly fascinating insight, but just as an example of the type of information we can start to, or the type of patterns we can start to expose using the graph database. I'll try and speed up a little bit. Oh, and then again, another SQL similar query. But just this was to demonstrate the union clause. So we can have, this would be one query, for example, where we're returning a count of all the bills that contain opioid. But we can chain queries together using this union function. So we can also look at a count of all the bills containing the word addiction and substance abuse. And then that'll return us a table like that. Again, similar to SQL. We're just showing how we can pull queries together into one result set. In this one, see, this is where the query starts getting a little more complicated, as you can see. What we're looking at here is to show how we can use the fact that we have network information about the bills and who are the sponsors of the bills, and then we know information about those sponsors and co-authors, how by counting those edges, we can start to infer something about support for the bill. So we're looking at 2016 only in this example, and we're going to count sponsors, co-authors, co-sponsors of a bill, and then break them up by whether they're Democrat or Republican. So then we can get some kind of measure of sort of bipartisanship and party support for these bills. We can also see which bill received the most support. You see how quickly we're able to do that because we have this graph structure. We're counting edges rather than having to move back and forth between tables and information about the legislators themselves and the bills themselves. We're able to pull it all in one set. Yeah. Oh, yeah. Right. Yeah, nothing I'm going to show you today is pre-prepared or cached or anything. It's all happening in real time on my laptop right here in front of me. There's no server or anything we're using today. Yeah, you can see this bill in 2016. Legislative session received the most support, and we have some, so this is just dividing this number by this number. So if it scores with 1, it means only Republicans supported it. But here we have one bill, only Republican support, carrying of handguns by member of employees of the General Assembly. Only Republicans voted for that one. Yeah. And then if a bill scores a 0, it means only Democrats supported. There's one. Well, I'm going to show you how I visualize this in a little bit. I don't see one right now. But you see here we have some here. 0.5 means equal support amongst Republicans and Democrats. But obviously the query is more complex to write, but you see how quickly we're able to run that one. Oh, and then just very quickly move through these. I just wanted to show how we can get an edge list and a node list out of this network, out of this database. So again, we're searching by a key term, and we just report. So here's our edge list from and to, and then for the same query. So here's the corresponding node list for the representatives, and then we can export these as we need to, CSV, JSON. So I want to show you those two because now I'm going to show you a visualization tool which we created using Shiny, which queries this network, this database, and uses this approach of producing edge lists and node lists to visualize network or to create network diagrams. So, so again, this is really a tech demo. It's not a finished product, but I just want to illustrate some of these queries and how they can be used from this point of view. So it's our first visualization. So if you remember that, I'm showing you the query which had Republican and Democratic support and was ranking, or at least producing this measure of dividing one by the other. So here we've visualized the bills introduced to the Appropriations Committee in 2014, 15, 16. So these are our 3 years in the database across here. And so you can see if a bill is scoring 0.5, means equal support. Scores a 1, only Republican support. Welfare, drug testing, employment. So these are bills which only had Republican support. And then down the bottom, bills that only Democrat support. Veterans Matters, and that. Removal of asset limits for SNAP. That's never mind what the supplementary nutritional assistance program. So that's for this committee. So these are only bills introduced to this committee, I should say. Obviously, the committee heard more bills, but there were bills which had been reassigned or recommitted from other committees. Just to give you a quick demonstration of how it works. So now we changed to Public Policy Committee. So now it's running that query in the background that we saw before, and then visualizing again the bills for this that were heard by the Public Policy Committee. And then this is not part of the database, but we can zoom in if we want to on a particular part of the graph. Oh, that's helpful particularly. So just to illustrate, how we can build some other type of visualizations which are available to us using a graph database is different, or not different, but perhaps we have more options than you would have with a relational database. So we can do this kind of analysis pretty quickly and on demand. We don't have to pre-compute any of these values or calculations. So then this one is the most sort of networky tools. The goal with this tool is you enter a search term. So before we were looking at the keyword opioids, one I often do. I used to work on horse racing and gaming legislation a lot, taxation. So I use horses. So this is using the example I had where it's creating, it's extracting a query, an edge list and a node list, and then plotting our visualization here and applying a clustering algorithm. Now this tool assumes that you know the difference between different clustering algorithms, which I do not, but I just listed them all out. I can click on them as much as anybody else. So you can try a different one. And it looks like we've got pretty much the same results. But just to illustrate, so with this network, so these are obviously legislators, representatives, senators. One edge in this network means that these two either both registered their support, co-sponsored, co-authored a bill which contained the word horses. So we start to see the networks of legislators who are interested in a particular subject. Now let's try to show a more interesting one. There you go. So this one's getting a little more messy. I realize this is a talk about visualizations, and these visualizations are not particularly easy to look at. But as I mentioned, this is just a tech demo to show you the type of thing we can do and how quickly we can do this kind of thing using graph database as the back end compared to a relational model. As you can see, these different clusters here being calculated by the algorithm, and conceivably with a little more refinement and work, something like this could be useful. If you're an advocate or a lobbying group, or you're trying to get a bill passed, you can start to pull out, identify who are the networks of legislators, what subjects are they, are particular senators interested in, and start extracting that kind of information. And then I want another one, which is sort of the reverse of that, which is the bills themselves. So in this case, an edge between two bills means that they've had one or more elected official support both bills, which is maybe less useful, I don't know, but we reversed it that way. Originally, I had this where it was both bills and legislators in one network visualization. This Shiny application was developed in collaboration with, or under the advisement or by request. I don't know what the best word is. I did the work, but he told me what to do. That's how it worked out. But by David Chartash at Translational Medicine, I think is the institute, the School of Medicine. So this was what he was interested in seeing and testing out with the database. So it was built to his specifications. But obviously, if you have ideas, we're certainly happy to try different things and change these around. I just think it's a useful demo, so how we can quickly get sort of graph information, or how using a graph database we can quickly visualize and explore graphical information. And there's one more tool, but full disclosure, this one doesn't actually use the database itself, but I can show you quickly. This is why it goes to 2017. So this one is querying the API directly, and then it pulls down a PDF of the bill that you select, and then it OCRs the text from the PDF and produces a visualization. So it's very simple, sort of linguistic. Is it going? Oh, hopefully. Well, maybe it's not going to work, so we'll solve that problem. I have to give it a minute. But this is based on the idea of the moral foundation theory, which I wasn't familiar with. I'm not an expert on it. But the idea is that when a person the theory is when a person makes a moral decision, they have certain value systems or values which they favor. So some people are more interested in following rules and law and order, where some people will put more weight on fairness and equality when they make a moral decision. And the theory is that, let me try another one of these, that people who value, so the fairness and equality factors to be more important are more likely to have more progressive or liberal political views, and people who value sort of rule following and law and order will have more conservative views. I can't tell you necessarily how accurate that is, but that's the theory, and that's what David wanted to suggest we look at. If I can get it to work here. 2015. There you go. And so, as I say, this is scraping the text from the PDF for the bill you select, and then it sort of counts the occurrence of the words, visualizes them in a graphic. Again, so this isn't particularly networky, and it doesn't use the graphic. So you can make it out, and here we have this is the count of words which the moral foundation theory research group identified as, if this word occurs, it means it's portraying harm, care, next in a positive way. These are also terms that come from their research. Words that occur, this is the count of words which you harm, care, index in a negative way. If fairness and reciprocity is probably easy to understand. So these are words which say fairness is good, these words suggest fairness is bad. And then across here. What's sort of interesting is you see authority and respect. Words which suggest authority and respect are pretty high for all of them because it's legal language, so it tends to sort of be weighted that way. Initially, when I created it, actually I did this as an aggregate, but I'm having most of the advice next to which I think is less intuitive, but it made sense to him. Yeah. Right. Yeah. That's possible. I wouldn't know, but this is just an example of sort of a very simple sort of text analysis that we can do. But yeah, if you're interested in that field, then certainly there's a lot you could dig into. And obviously, this requires that you sort of know what bill you're looking for in advance. So obviously, it doesn't tell you really anything about the bill. So Sorry, it's more sort of Olga's field, text analysis. Leave it up to her to do this kind of thing. But anyway, so go back to my slide. I know I'm going to mess up Olga's live recording now by going back to it's not a very interesting slide. I just wanted to finish with a quick, what do we want to do next with this project? Find it. There you go. It's worth switching back to see that slide, right? So what do we want to do next with this database? Obviously, we'd like to include more data. That'd be great. But as I say, more often than not, since this was produced, by myself without a particular research question in mind, we often use it as a sort of demo in this kind of situation to show, well, here's a graph database, here's some tools and network visualizations we can produce. Ideally, we like to find, we're happy to partner with people and use it for research and make it available. That would be great if we could find a real purpose to sort of drive this and develop some kind of web application where it's open to the public and people can come and do research on the state government and visualize it. But then potentially, we are working on a project right now where we're looking at opioid abuse and public services in Indiana. So conceivably, we might roll it into that and start pairing it up with some public information about public services and how, who are the elected representatives for those locations, what fields are they interested in. There's a few different ways that it can go. But really, what happens next is up to our partners and whoever wants to come and explore the database. So I'll finish my contact information if you have more questions or if you'd like to learn more about it. But I think you have 5 minutes to spare, so that's my presentation. So any questions? I'm happy to take questions. I mean, conceivably, that might be a question for Patty about how my time is allocated, but certainly I'm happy to work on Graph. Certainly Neo4j, we've been working with a fair amount, simply because it does have this fun interface and it's pretty easy to pick up. And there's a lot of resources out there. Yeah. Yeah, no, absolutely. I mean, it's an interesting, it's a very different approach from coming from the relational SQL-based model to start thinking in graphs and start using Cypher. And there are a lot of resources which Neo4j puts out about how to sort of translate your thinking from SQL to Cypher and from tables to graphs. It's one of their less helpful features, but it's kind of fun to visualize. If you get to a node like this, you can click on this little button and it'll just expand everything that's connected to that node. Isn't too helpful, but it's kind of, you get to play around with stuff and see what's in there. Yeah, these are bill versions of bills which have been sponsored or co-authored by Representative Clare. Over here, these are committees. So these are the committees these bills were assigned to. And that probably means different years. So it'll be public policy 2015, public policy 2016, slightly. Yeah. Yeah. Mm-hmm. Yeah. Yeah. I mean, apart from at the top here, sort of a color code, so the assigned to edges in red, that's the closest thing it has. But I mean, the idea with this tool is, to be a query browser, like a sort of MySQL workbench, but for graph database. I mean, it just makes these fun diagrams. But yeah, it's really just the thing. I think it's not intended, at least, to be a sort of front-end tool, but really it's for developing the database and demoing it like this. Really, you build your own front-end probably in most cases. But yeah, I mean, but I guess I should say it is open source, I believe, and it's all written in Java. So if you are a Java expert, you can certainly hack on base Neo4j and add in your own features if you want to. That's beyond my skill set, certainly. Yeah, and certainly you can make better looking shiny apps. The one I've demoed, this is kind of a basic one, really. I was more focused on interacting with the graph database and making something that looked super nice. But if you see some older shiny apps, they look much more professional than this one.